In this video, we're going to learn all about carbon capture, what it's like to be an engineer working in that sector, how to get involved in this industry, how the technology works at a company like Climeworks, and specifically for you, 1% Nation, how to get hired at one of these companies, what do they look for, how can you actually have a career changing the world and becoming a part of a sustainable engineering ecosystem. All that and more coming up, and we're starting right now. Hey 1% Nation, I'm Jake Voorhees, and welcome back to the 1% Engineer Show, where we empower young engineers to rise to the top 1% of their career. So if this is you, make sure you hit the notification bell and subscribe. Check out the links below for lots of great things, like access to our Discord server with over 900 engineers, the IG page ran by Rose featured in this video, the 1% Engineer Kit, and more. Today on the show, we're featuring a conversation between the Director of Research and Development, a PhD chemical engineer named Natalie Casas, who's being interviewed by Rose, Delaney, and myself. Rose is our director of Instagram. You've probably seen her in other videos like with Luis. This video has tons of value, and the first part really goes over Climeworks and their technologies and how carbon capture and companies like Climeworks are making a huge impact and trying to reverse global climate change. After that, this interview focuses on how to choose the right engineering focus for you as Climeworks hires electrical, mechanical, chemical, all types of different engineers, and myself, Natalie, and Rose talk about our journeys to choosing the right major. We also talk about how to get into companies like Climeworks, what they look for, what a successful engineer looks like, and all types of engineering tips for your success. Comment below, what are you trying to figure out, what videos should we make next? There's a lot of great content in this video, so I'm going to make sure to have show notes in the description and try to add the YouTube chapter information for the first time. So without further ado, let's get right into this conversation between Natalie, Rose, and myself. Enjoy!
Hi everyone, my name is Rose Delaney and I am an electrical and electronic engineering student from Ireland. I'm a board member here at 1% Engineer and my main role is the director of the Instagram page. I'm here with Natalie, head of research and development at Climeworks in Switzerland. So Natalie, thanks for coming on the show, and we'd love to hear a bit about yourself and your path to becoming head of R&D at Climeworks.
Thanks a lot from my side for the invitation to talk to all these engineers out there. As you said, my name is Natalie Casas. I'm the head of R&D here at Climeworks. And you asked me to talk a bit more about myself. So how did I become the head of R&D here at Climeworks? So I'm a chemical engineer by training. Then I did a PhD in process engineering on the topic of CO2 capture by means of absorption. So I was looking during my PhD exactly at the technology we are using here at Climeworks. After that, I went to a big Swiss industrial company and I kept working on CO2 capture using another technology, but still, the topic of CO2 capture was fascinating me because I think it's one of the biggest challenges we have, or mankind has, is climate change. And I really wanted to use my skills as an engineer to be part of the solution.
Sounds great. Would you like to tell us a bit about Climeworks and your company, your vision, and Climeworks technology?
Climeworks is one of the few companies worldwide doing DAC. What does DAC mean? So DAC is direct air capture. This means we are pulling CO2 out of the air and producing pure CO2. This CO2 can then be either stored on the ground, so we really remove it from the atmosphere, or it can be used as a raw product to produce anything else. And this is referred to as the circular. And for these two applications of the CO2, we team up with other companies or other partners doing the second step. So Climeworks really focuses on the removal of CO2 from the atmosphere. We see ourselves also as a solution provider. So we realized that we are building machines. It's for an engineer, this is great, it's nice. It's a lot of hardware, it's a lot of technical things which are nice, but most people don't care too much about the machine itself. They want to have the solution. And this we try to provide in order to team up. As for example, in Iceland, we have a partner which is Carfix. They are doing CO2 storage underground in geothermal basalt. And teaming up with them, we are able to provide the people or companies with CDR. CDR means carbon dioxide removal. So this is something which we offer as a solution. So you can buy from us negative emissions. And our vision is to inspire 1 billion people to reverse climate change. Meaning that we are completely aware of the fact that we cannot do it ourselves. So we are part of the solution. We are one little solution of in order to solve the problem. But we want to make our solution accessible to everybody. So we have also a web shop. So we offer it to companies, but we have also a web shop where every individual who wants to contribute, even a little amount, to removing CO2 from the atmosphere, can sign up and buy a very little amount or bigger amount as
so as an engineering student, a young person entering my kind of engineering career, it's definitely very important to me to have values such as sustainable engineering practices and ethics within engineering. And I see Climeworks as one of the main companies with such values at their core. So what are the next big steps that Climeworks are planning to take?
Yes, so I'm very happy that we are perceived this way, because I also think we are doing, or we are working to achieve this goal. And what are next steps? So in the last 10 years, so Climeworks is 10 years old, we built small machines from demonstration plants. So we went from the idea from a PhD from university to small plants, to bigger plants, to even bigger plants. And we have, I would say, 2 medium scale plants up and running, where customers are buying CO2 from us. And the next step is a plant we are building in Iceland, which is a bigger plant. So it's 4,000 tons per year plant. So 4,000 tons means 4,000 tons of CO2, which is extracted from here in Iceland and stored underground. So there, most of my team is working on at the moment, or let's say half to 3/4 of the team. And it went from development. So we have a lot of people working on development, developing new ideas, new concepts from different angles, different aspects, through engineering, and now the plant's in production. So it will be commissioned beginning of next year, and starting, I say, from February, March, it will be operational up in Iceland.
Sounds really great, and it's such a big move to go to Iceland from Zurich in Switzerland, so that must be very challenging. I'm wondering about the development and optimization processes and strategies that you use at Climeworks. So as head of R&D, I suppose you're over a lot of engineers and a lot of teams. So what kind of practices do you use in those teams to come up with the great ideas and solutions that you are coming up with?
Yes, that's a very good question. So our target or our goals are very ambitious. So there's a lot of CO2 which needs to be removed, and it needs to be done at a rather low price. Otherwise, people will not be willing to pay for it. And therefore, we need to be fast. And engineering often is not so fast, because you need to be thorough, you need to work everything out, and if you don't plan something well, it will be expensive. But in the development phase, we have adjusted the agile development method, which was originally developed for software development. I think Google introduced it, and also other companies. And what does this mean? So we bring ideas on the table, and we do a risk assessment, and we try to test these risks at the early stage. So one example is somebody comes up with a new structure, so a mechanical engineering idea. Then we evaluate the risk, and one risk could be stability. And what we then do is we build a small prototype to tackle this risk before we spend any more resources or money into this idea. And then if this biggest risk, so the investability, is mitigated, we can move on. And this is, I think it was very successful method over the last 1.5, 2 years to move on very quickly. So we could take on a lot of ideas because we try to identify the risks, then check them out, and if something failed, we could rather move to the next idea instead of working out an idea and then at the end, after half a year, realizing, oh, so that's something innovative we are doing, I would say, and not that many mechanical engineering companies do.
It sounds like a lot of planning goes into these designs. So from, as you said, mechanical engineers, but what other types of engineers do you employ at Climeworks?
I would say all kinds of engineers. So we have mechanical engineers, we have electrical engineers, since our plants need electricity, valves need to open and close. We have automation engineers. There's a quite sophisticated control system behind everything because we need to make sure to operate at the best possible condition and process. So there are a lot of thoughts also in this respect. We are about we spend quite some effort in digitalization as well. Yeah. So there we have process engineers, automation engineers, working hand in hand, software engineers. And they are working on building up a digital twin. So, I learned from Accenture, which is a partner from us, that the newest trend is the dark plant. And dark plants, why are they dark? Because they don't need people on site. This means that the control needs to be very good, and that the digitalization needs to be done in such a way that a lot of things could be done. And this can be, as I said, a digital twin where you see quite in advance if something will be going wrong in the future, you can react early enough. So there we have also people doing statistics on all these curves we are measuring. So we have a lot of sensors there. And if you see, okay, one pump needs a bit more electricity, and you have your model backing this up, you can say, okay, this pump, in 2 months, most probably it will fail, or it will need some replacement of some parts. And this is also something we are investing quite some resources and thoughts in, because we think that's the future. So if we have a lot of plants out there, they also need to be a bit independent. So we don't want to have teams of 20 people on each plant if we need to remove a lot of CO2.
This is really cool. I've never heard of this. Let's talk about this for a second, Rose. So a dark plant. So a dark plant is a plant with absolutely zero people there, or is it the very minimal team where, like you said, like maybe 20 people need to be there? I'd love to learn more about this because I've never heard of this concept. This is awesome.
Yeah, I think the less the better. So I don't know what at the end it means for our plants, but the idea is to have, let's say, 0 people on site, but a system which sends an alarm if you need to bring something on the spot. So I think there's no machine which needs no maintenance, or no plant who needs 0 maintenance. So we need to make sure that this maintenance can be done, but we want to know it in advance. So if we realize based on models, okay, something will fail, we send somebody there. But in principle is there's nobody, or maybe one person doing the security check in the evening, and people go on site if required. So that's the dark concept.
Very cool. I mean, immediately it makes me think of Chernobyl, right? The biggest plant upset in the history of the world, or at least, and a lot of people are like, oh no, we don't want to rely on the systems. We don't want to rely on the autonomous things that we've established. But it's like, I come from a driverless and a traffic engineering background, okay? And everybody's like, oh no, I don't want my car to drive myself. It's unsafe. It's like, no way. This car is way safer than the decision-making of humans. And a lot of the Chernobyl thing was people, they made mistakes and they covered it up. And a lot of times when you take the human element out of things, there's this massive amount of systematic improvement. So this is another example of it, guys. I'm really glad you brought this up, Natalie. Thanks for expanding on that. Go ahead, Rose.
Yeah, do you think Climeworks will ever have plants like that with 0 people in them? for most of the time anyway.
Yes, I definitely think so. I don't know if the first plant we build of a certain type will be really dark. Probably not, because the first plant you build normally has some flaws, which you need to learn about and to be able to correct it. But I definitely think that must be the way we have to. So we will go. And yeah, I think that that's, as mentioned, it's a way many technologies go, right?
Yeah, that sounds amazing. And when the engineers and the people maintaining the plants are kind of taken out of the plants, they'll have more time to work on different ideas and maybe improving what you already have. So that is always a great way forward. For yourself as head of R&D there at Climeworks, what does a good engineer look like to you? So what qualities and values do you look for in your employees?
I did a lot of hiring over the past years, and one thing I always liked are passionate people. So people with ideas, and they convince me that they like what they're doing. Because I think there are many smart people out there, but there are also people which don't like too much what they're doing, or they're doing it for a certain purpose. But I think if you like what you do, then this will help certainly. And I think most people applying for this position are very smart. So I wouldn't say that good grades make the difference. It's really the passion and the dedication to purpose which makes the difference. So if you talk to somebody, you realize pretty quickly if this person is passionate, and our company purpose or vision meets with their personal values. And I think in our case, since it's like climate change, and I would say most people in our company are purpose driven. So this is a huge advantage for us. I think often if you think about people working in a bank, I don't want to, there are certainly other ones, but many of them are probably money driven, or maybe that's one thought I have. But these people are not applying with us. So I think people coming to us, they're really purpose driven.
Yeah, I have a lot to say about this because, a lot of people in engineering, they get into it because they're smart and they're good at math and it makes pretty good money. And then they don't end up finding that passion, or even oppositely, when you're, Rose is the second year in university, if you're towards the end or middle of your university days, because this channel is like 55% 18 to 24-year-olds about to work at Climeworks, about to work at some other firm, right? And if you show up to that interview and you're like, this is what I want to do, and this is what I've been working on for 10 years, and all my internships and all my tech electives and all my relationships and the volunteer things and the things on my resume, and it all has this plan of where you're going next, it's really hard for people in your role, Natalie, to oppose that. It's like, yeah, I want to give you a shot. Like, this is exactly what we want in our team, because that person isn't driven by the wrong things. And when times are tough, and when maybe, hey, we didn't get bonuses this year, it doesn't matter. That person is going to show up. And then on top of this passion, you guys have this other thing that is impact, right? You guys are actually changing the world. And so it's hard to not feel passionate about that sort of thing if you're into sustainability. So I'm really glad that you said this, Natalie. Thank you for that.
And another aspect, it brings a very nice working culture into the company, because people coming to us have the same purpose, have the same goals. They want to make a change. So there are many people, so that there are initiatives in our company. Many people come by bike, and there are some, I would say we have many people which care about the environment and also do some hobbies together to see how this could be implemented in a daily basis. I think we have a very nice recycling concept in the company, so we are separating all the waste, because one of our employees thought that's very important and took the initiative, and now it's implemented. So that's very nice. So we have people coming with a lot of passion, a lot of ideas, and they also bring it to the company, which is very cool if you work there. to see this passion and this purpose in the young people.
Yeah, definitely for myself, having that values, the set of values that match the company that you're going to, that is something really, really important to me. As if you were to go back and start all over again, what advice would you give to a young engineer starting out?
Yeah, I would certainly do something you like to do. Don't do it because you think it's the path you need to be successful or something. Because sometimes you plan for something, but at the end it will turn out completely different. But I'm convinced if you like what you're doing, you are good at it, you have this passion, you have this extra glance in your eyes and the energy. So I would say that's the best advice I can give. Don't do something you don't like. Follow your heart, follow your gut feeling. And sometimes it's hard here. If you are at university, you have to study for exams. Exams are hard. You might fail. Many people fail. You fail. You have to do it another time. But if you like it, it's worthwhile. So keep on going. And at the end, I think it's not the grades you have. It's really about what you want to do, what you like to do, and to transmit this passion.
Yes, I'd love to have you expand something there, Natalie. Great question, Rose. So we help young engineers with three things: getting that job after university, how to actually succeed in university with things like building mentorship opportunities and relationships with professors, and how to, we don't teach engineering, we teach how to be successful at engineering. But before we can help students with those two, far and away, the loudest voice of concern is choosing the right engineering major. And so they actually struggle with how do I even know which one is the one? And so, Natalie, you come from a background of, chemical engineering all the way into you have your PhD in chemical engineering. So if you could, I'd love for you to step back into the early days and what are some tactics you could give some young students to know, how did you know that chemical engineering was the one for you? Because clearly it's worked out great, but how did you know? I see this anxiety in the comments. It's insane. So if you have anything to say about that, we'd love to know.
Yes, so I can tell my story. So I was graduate, or I did high school, and then I like biology, I like chemistry, I like physics, I like math. So I was exactly in the situation, so what should I do? And then in Switzerland, we have, so for certain classes or for certain programs, you need to have an internship, and for others, you don't. And then I gave myself a limit. And so I boiled it down to two, so chemical engineering or material science. So these were the two on my list. And then I said, okay, for material science, I need to have an internship. If I have it until a certain date, I think it was June 6th, I will do material science, and if I don't have an internship position by June 6th, I do chemical engineering. And I got an internship position, I think it was June 7th or 8th, so 2 days too late, but I made my decision. But I think you need to narrow it down, and most probably engineers have one thing they like a bit more than other things. Or in my case, it was like this. Rose, you are an electrical engineer.
Yeah.
Why did you choose electrical engineering and not mechanical or chemical?
That's actually an interesting story, because in first year of my engineering degree, I came in with the idea that I was going to do process and chemical engineering as well. And once I had the chance to try out 4 different types of engineering, so that was process and chem, electrical and electronic, civil, structural and environmental engineering, and energy engineering. So I got to try all of those in first year. And then once I had tried them all out and got more practical experience with them, it was definitely electrical and electronic was the one for me, because it's the one I definitely preferred the practical side to. And honestly, when you go into the workplace, it is the practical side that you'll be working with. It won't be can you write down loads of maths equations on a piece of paper? You'll have to use your head and think. So definitely that's what made me choose electrical and electronic engineering.
So guys, by the way, there's a lot of schools that do exactly what Rose's university did, where they expose you to a series of different types of engineering, because it is very hard to know what you like until you discover what you don't like. You get it and you're like, you thought this was it. And it's like, oh, actually, I don't like this at all. You really don't know. They build up this romantic idea of like, oh yeah, chemical engineering is for me or mechanical is for me. But you don't really know until you get to that practical doing it part. And even for me, so I was a freshman, I'm 33. So I was a freshman in engineering in 2005, and I went right into civil engineering. And now what they've done, they've evolved it so that you actually don't, at the same university I went, they've evolved it so you only go into general engineering in your first year. And just like Rose's, they expose you to multiple lanes of engineering so that you don't go in blind, because you really don't get into those core classes until like year 3. So it kind of doesn't matter anyway, and then you've taken sort of the wrong classes, and you can lose a year, even if you have to switch within engineering, just because there's so many specific technical courses that, like for Natalie's case, only I didn't take any of the chemical engineering classes. That would be insane. Thermodynamics. I'm a civil engineer, right? So I'm glad to hear that. So you got to get out there and figure it out, guys. And if you don't have any university, like if say you have a scholarship and you're pigeonholed into the one that doesn't have a series of experiments or examples, then you have to go out there and figure it out yourself. Informational interviews, that's the way. And we have videos about that. So yeah, great questions. Thank you.
Definitely talking to people helped as well. Talking to even the older students last year, there was like, I made a few friends with on societies in the college, and getting to talk to them, it kind of gave me a bit more of an insight into what each engineering discipline involves. So that was definitely a great way of finding out what I'd be doing in second, third and fourth year. So that was a great way of getting to know what different types of engineers did. As a woman in engineering, have you faced any challenges throughout your career?
I think that's a very good question, and my view on this changed a bit, and I would say it's also very country specific. So I'm not sure that the challenges I'm facing in Switzerland or I face in Switzerland are the same in other countries. But I started university, and I was convinced that everybody is equal and that there is no challenge. Of course, we were very little female students in this field. But it was okay, so we were treated well, and if you performed and you were able to do the exams and everything, I think we were respected as the other were. So I never had the feeling to face some disadvantage being a female. And I started my first job, and same thing happened. So I think in Switzerland you even have some small advantage, because many big companies, they have like this equality and gender topic on their flag, so they are really eager to employ female engineers. And when it started to come into my mind that there is a difference is when I had a kid. So when I was pregnant and I became a mother, things slightly changed. And I think Switzerland is rather conservative in this respect. So people started to ask me, yeah, but who will take care of your kids when you are at work? And this question drove me mad, because I said, nobody will ask my partner or my husband who is taking care of your kids when you become a father. Then I realized that there is a difference. And as a female engineer or a female employee, at least in Switzerland, you have to work harder to prove that you want to work, you deliver what you delivered before, and that you manage to manage everything. And that really having a child was the moment in my life where I realized, okay, there is this inequality. And the thing is that this happens normally between, let's say, 30 and 40, or at least in Switzerland, this is the case. I don't know about other countries, maybe similar. But if you study, you do PhD, and you work some years, it's the age you are. And that's the age where you really can work full speed. So it's the age where you have the highest impact, careers are built, people get promoted, others don't. And if you have a kid in this time, it's even harder because you need to prove that you also want to contribute, you also want to be the one to be promoted. So I think there, it's for me it was really good. So my mom was always working. For me, it was clear that I don't work. And I don't want to work. In Switzerland, many women start working part time, so meaning 50% or 40% or 60%. I don't know how it is in Ireland or the US. But for me, it was always clear I want to work 80% or 100%. So the full spectrum. And I think that's also required if you want to be promoted and have a job where you have a responsibility for people. So you cannot work 40% if you want to be head R&D. And this was clear to me. And yeah, for me it was clear I want to do this, and I'm also willing to give an extra effort.
Great to hear a really great success story from another female in engineering. It makes me think it's all going to be worth it in the end. So yeah, thanks for sharing that, Natalie.
And Natalie made some good points about how it's always country specific, whether it be the gender conversation or even employability. One thing we talk a lot about is the employability of a chemical engineer in North America. And so the big three are civil, electrical, and mechanical. Each of those has over 300,000. There's only 33,000 employed, so 10% of the big three. Only 33,000 chemical engineers employed in America, okay? And then I was looking at this website. We've created what we call saturation ratio, okay? So if there's only 33,000 employed last year, I have this website that shows that 11,000 chemical engineering degrees were awarded, right? And so this is a big issue, right? And so there's a lot of chemical engineers who in America and Canada, we have one on our team here, Valentin. He has a chemical engineering degree from a great school. And what some of these people do is they build up peripheral skills and then they end up in mechanical engineering, or they end up in coding or something like this. So I don't know if you can speak to that for a greater European perspective, or maybe if you guys hire engineers from around the world, but I'd love to ask you really quickly about your view on the future of chemical engineering. I think is really the question for the suitability for being hired right away, things like this, Natalie.
I think in Switzerland, at least, so they're very little. I think we're about 10 chemical engineers graduating from my school in my year. And we have a big chemical industry looking for chemical engineers. So there's really a lack of skilled chemical engineers in Switzerland, and I think it's also in Europe the case, I would say. And the other aspect of chemical engineering is that it's a very broad topic, I would say. So at least my degree was chemical and bioengineering. So it covered topics from sustainability, like CO2 capture and materials which are sustainable. So I have friends, they develop materials for jackets without microplastics and stuff like this. So there's this whole sustainability topic which is covered, as well as the bioengineering topic. So there's a lot of medical engineering as well. So, for example, I did during my master thesis, I was engineering the formulation of the drug. So it was, how could you formulate insulin? So if you have diabetes, you need to pinch yourself, I don't know, every time after lunch, or to get this sugar level at the same, for the sugar on the same level. And we were looking at how could we bring this drug in a form that you just have to do it once a day, and it dissolves over the day and can react on what's happening to your body. So from my perspective, I think chemical engineering or chemical bioengineering is so a broad topic that it covers a lot of these mega trends we have today. So saying one mega trend is this whole sustainability topic, reaching from climate change over microplastics in the environment, nanomaterial in the environment, down to this topic of medical engineering, where people getting older and older, and I think there will be always more drug topics, targeted drugs, how we can deliver it better to the people without causing harm to them. So this is the spectrum of chemical engineering at the university I was studying. I'm not sure if this is exactly the same in other universities. I know in many universities there's the petroleum engineering, which is quite close to chemical engineering, but
You said petroleum engineering. Yeah. So it's kind of funny. You're right. It's depending on who you're talking to, they associate them much more closely. And I think it comes down to the country of origin, like how influential oil is to that country. So
yeah.
America has oil, UK has oil. A lot of countries in the Middle East, they have these programs that are very, even if it is a chemical engineering program, is very built to be a petroleum engineering program. So yeah, that's a really good point, Natalie. Did you have anything else to add to that, Rose?
No, just to add that the demand is country specific. So I know here in Ireland there are lots of chemical engineering companies, especially here in Cork, and that's why chemical engineering was like I think most people in my course actually went on from first year to do chemical and process engineering. So that is a big kind of section here in Ireland. And a lot of companies like Merck and AbbVie employ all the chemical engineers from UCC, which is my university. And they are like really popular with process engineers specifically. So that's it. All depends on where you are in the world, really.
Yeah, I realized also when we have open positions, we get a lot of application from petroleum engineers because they want to move away from this petroleum or this industry. So
they know we're not doing oil forever. They know.
Yeah, they know, and
they know.
And I think so. Their skills are very useful also to us, for example. So per se, what they learn can be also applied in other industries. So yeah, I think the name is not so appealing, maybe because there will not be petroleum forever, but the skills you get there are not just for petroleum engineering.
Yeah, that's right. And one final thing. So for me, because really, really great job with all the questions so far, Natalie. So you have another interesting perspective because you have a PhD. So I meet a lot of engineers who are like half the age of students today, like literally in their teens, preteens, and they've planned out exactly where they're going to get their undergrad, their master's, and their PhD, and they know where they're going to do their postdoc and all of this. And so, and I've also talked to a lot of PhD engineers who are like, yeah, they did it, and then they're not sure if they should have, and this type of thing. So I would love to hear your perspective on people who know they want to have a research focus of their career, because if you want to be a professor, you have to get a PhD. But if you want to work in the industry and be more of the research sort of track, it's optional, and you have more potential with that PhD. And you have done really well for yourself, Natalie. You're leading this R&D department. I'd love to hear your perspective on that PhD. Would you be able to head R&D at Climeworks without that degree? That's kind of like the precursor question, and then you can go from there.
I think if you want to be head of R&D, you are better off with a PhD, I would say. Definitely. I think if you do research and development, you don't need it. It can be beneficial if it's on the topic you're working. And I must say for myself, so I started studying, and I always say I will not do a PhD. It's not useful for what I want to do. It will not bring me much. And then I did my master's, and I really liked my master thesis. I liked the professor. I liked the group. He offered me a PhD. And I said, why not? I liked it so much. Why should I not really. And then I did the PhD and I really enjoyed it. So I learned a lot. I learned a lot about research and I learned a lot about how to lead a project. And I say, you never have the time again to look into a topic in such details like in the PhD. You have like 4 years time at least in my university to really dig into something, which you will not have any more later on. So if this is something you're enjoying, I would recommend to do it. Just doing a PhD because you envision yourself as head R&D might not be the right thing. So as I said before, you should do things you like to do. And if this is something you like doing, then it's certainly worth it. If you don't like it, probably you would also not enjoy being head R&D later on.
Yeah, one thing to add about the research is definitely as an undergraduate, try get into a research program before doing 4 years at it, because 4 years is a very long time. Whereas if you spend maybe 10 weeks during your summer doing a research project, you kind of get a little bit of a feel for what you're heading into. So you kind of have an understanding of what is required, what is needed, and what is expected of you when you are carrying out a research project. I know I did a research project just last summer for 10 weeks, and it was in the field of computational biology. And it was like a really interesting project, but it wasn't fully focused on electrical and electronic engineering, which is what I wanted to do, but definitely the coding aspect and things like that helped. So I know biology is not for me now, but the maybe software and design element is. So it's great to get experience if you can when you are heading into the research side of things. Otherwise, I think I have all my questions asked. Natalie, is there anything else you'd like our viewers to know?
I think you asked a lot of very interesting questions. Thank you for that. So I enjoyed talking to you. So from my side, nothing more to add.
Thanks so much for coming on and doing this interview with us. I'm sure our audience would find this interview really informative and helpful when they are looking at different companies. So definitely it was a great learning experience for me. And I hope you enjoyed it as well. So thanks very much.
Thanks so much. Where can people learn more about what you're up to in your career? Sometimes people like viewers to connect with them on LinkedIn. If you don't want that, that's okay. But also, where can we learn more about Climeworks? Do you guys have a blog? Are you active on social? I'm pretty sure I've seen your social media pages. But if people want to learn more about either you or Climeworks in the future, where should they go, Natalie? This is where we need Rosanna, maybe.
We are active on Facebook. We are active on Instagram. We are active on LinkedIn. I myself have a LinkedIn account, so there one can add me or friend me. I'm not always very fast in answering requests because there are quite some requests, also questions to Climeworks, but I'm happy if I can help young engineers to make decisions and give some guidance if this is required or wished.
There you go. Future chemical engineer, send Natalie a note. She asked for it. All 70,000 of you. No, I'm just kidding. Cool, Rose. You can close us out. Go ahead.
Thanks very much, Natalie. And hopefully you enjoyed this experience anyway. So enjoy your Friday evening and the rest of your weekend. Anyway, thank you.
Very cool.
Thank you.
Thanks, Natalie. Bye-bye. See you guys.
Hey, 1% Nation, Jake here. I hope you enjoyed that conversation between Natalie, Rose. If you did, we release videos multiple times a week for your engineering success. So if you're a young engineer and you want to rise to the top 1% of your career, consider subscribing and hitting the bell. Check out the links below for more free things like our Discord server, 1% Engineer Kit, and access to the IG page that Rose herself runs. What types of videos should we make in 2021? Comment below. Let us know how we can help you the most, and we'll see you again in another video. Thanks again, 1% Nation. Bye-bye.